Welcome back, friends. Let's understand LangChain using DeepSeek-R1 model. To understand LangChain with DeepSeek model, we are using this environment where the model from DeepSeek is hosted on my local system. I'm running the local model using Ollama. You can download Ollama, you can install it, and you can pull the model. Model will be on your system, not going through internet or not going through API, or not, your data will not leave your system. Your data will remain with you. So this is Ollama running right now, and this is my Jupyter notebook. In order to understand this, let's continue with the session. This is LangChain with DeepSeek-R1 model. Goal is to provide an understanding of LangChain components and LangChain examples. LangChain is a framework to build enterprise solutions. You can't think of enterprise solutions directly with large language model until and unless you integrate it with other components like templates, agents, document loaders, retrievers. We need more components, comprehensive components, and put them together, connect these components together to build some kind of enterprise solution. So LangChain is one such framework which can help you with that. So LangChain with the DeepSeek-R1 model. LangChain is a framework for developing applications powered by language models. It makes complicated part of working and building with AI model easier. It helps in two ways. One is integration. You can bring external data like your files or application or API into your large language model. Second, agents. You can build agents, you can call agents, you can use even Google search to fetch the data from Google and then synthesizing it using large language model. So LangChain is a comprehensive framework that gives you complete solution for building enterprise level solutions. So I have already installed this. I'm not running this again, but if you want, I can just show you that I'm running it quietly. So I'll just expect number one, and import operating system, import chat Ollama. LangChain Ollama is installed on my machine, and string output parser. So we are importing these packages. Then let's understand the components, the building blocks of LangChain. The building blocks of LangChain start with even the chat model itself is a component. Chat model, prompt template, all these are building blocks. So let's understand the components that can make your chain much more powerful. So chat model, we are using chat prompt template, Ollama LLM, human message, AI message, system message. We are importing these packages to understand. So this is our first definition, that where the LLM is. So you can define, give this LLM maybe A, B, C, D, donkey, monkey, any name to it. But we are defining ultimately an object which is using chat Ollama. The model is DeepSeek-R1 latest, hosted on my local system, running through Ollama. You can see localhost 11434. It is on my own MacBook. So model imported and the model defined, I mean the variable defined. Now this is one component that can have message as a component of your LangChain, and that message can come from human, that can be helpful background for the model, that is system prompt, or human message, or AI message, means that could be the response from the API or a response from the model in your previous interaction, or human message. For example, you are a nice AI bot that helps the user to figure out where to travel in one short sentence. So this is the system message or the preamble. And human message, I'd like beaches, where should I go? So this is the human message, and you should go to France. Imagine this is the response. Right now we are hard coding it, but in programming we use this as the answer of the previous response or previous question from the model. and what else should I do, or shall I do when I'm there. So this is a message that can be the chat message which can be used. So what we expect is this one. So this is the response. We are printing the response from the model, and this is what the response from the model is. Similarly, we don't need to add AI message or system message if you don't want to. It is you can exclude these messages if you want. So for example, in this case we are only using the system message. So write an article in 2 paragraphs on LangChain. So we expect a simple article on LangChain in 2 paragraphs that will be created by this model DeepSeek-R1. Then prompt. These were chat messages that can be part of the LangChain. Now this is the response. Next is prompt. Prompt is what you send to the model as input. Prompt is your initial content that goes to the model, maybe your question or background context or anything what you send to the model. So this is prompt. LangChain Ollama, import chat Ollama, define the model, and this is the prompt we are creating. That can be a part of the LangChain. Basically, LangChain helps you connect a one dot, like for example, okay, let's take one input goes to one chain, the same input goes to another chain, output of one chain become input to another chain, then output of this another chain, like okay, let's look at user input goes to chain 1, output of chain 1 become input to chain 2. Same output goes to chain 3 also. Output of chain 3 becomes input to chain 4. Same output from chain 2 also become input to chain 4. And the output of chain 4 is final. So that's how we can connect multiple blocks together using LangChain. So one such component that can be used is prompt. Then prompt template. This is the prompt. We are just defining the prompt which we have been using in the previous prompting techniques. Then prompt template. So I really want to travel to Delhi. What should I there? This is my template. If you look at this carefully, this is a template where we are substituting the value. Template is the placeholder where you define some content, some text, and you add a placeholder of variable substitution place. For example, I really want to travel to location. So location is a variable that will be substituted at runtime. What should I do there? Respond in one short sentence. And the prompt template is defined here. Prompt template, input variables is location, and template is template. So this is calling this template here, and now this is my final prompt with a variable name location, and the value is Delhi. So what will be the final prompt? That I really want to travel to Delhi. What should I do there? That will become the final prompt, and that's what you can see here. I really want to travel to Delhi. What should I do there? And this is the response from the model. I'm printing this final prompt and the final output from the model, and this is what model is suggesting. You should go to Red Fort, or you should go to these locations, suggest where you should visit. India Gate, you see here. So output parser is very interesting. To extract the meaningful output or structured output from the model, you can send instructions to the model itself. Output parser is basically schema which is used to generate the output in a specific format, because you probably want to integrate that in a solution in the software where you will need the output in JSON format, for example, with key and value. So we are using response schema, structured output parser, prompt template, and chat Ollama. Importing again. And look at the schema definition here. Name is answer, description is answer to the question. Second one is, let me pull this together so that you can understand it easily. So name is source, and the description of the source is source used to answer the user question. So this is my response schema with answer and source, 2 elements. Then I'm defining the output parser with structured output parser from this response schema, which is defined here. So this defines my schema, output parser is created. These are my format instructions using output parser. The object is output parser, which is created from the schema, and this will generate the instructions for formatting the output from the model. Now I'm creating the prompt from the template. Answer the user's question as best as possible using format instructions, which is defined using the schema. And the follow-up, the question from the user is stored into this placeholder variable. So input variable is question and format instruction. This is defining the prompt. Now we are defining the model, which is chat Ollama with DeepSeek-R1 model hosted locally, and this is the chain. Prompt goes to model, output of model goes to output parser. This becomes the chain where three components are being used. One was the prompt, second was the model, and third was the output parser. And now we can invoke the chain with the question, what is the capital of India? So what do we expect output of this question? We expect the output in this format, in JSON format, where I should expect the answer plus the source. And this will give you more auditable and better answer from the model, and you will expect that in the same format. So you see, output is Mumbai and source is memory and basic knowledge of geography. So that is hallucination. Capital of India is not Mumbai. That is that's a very interesting fact you just now observed from about DeepSeek-R1. So never ever trust the output from these models. Have your own verification system in place. That's the good learning team. Now documents. From LangChain schema, import documents. These are also components of LangChain. This is a document, hard-coded document with some metadata. You can define your own keys with their values. This is a document which can be a part of your component of your LangChain that can be used in the LangChain. And here the document is defined with schema. Second is a document without schema, without this metadata. So we don't need, it is not mandatory, you don't have to include metadata if you don't want to. So we are not using any metadata in this example. So this is a hard-coded document. Second is document loaders. There are hundreds of document loaders to load content in the form of text from various locations. This location can be Hackers News, can be Gutenberg project where you have 70,000 websites available. And it can be unstructured parser also. You can use unstructured URL parser which can load from content from the website. There are hundreds of possible loaders. So let's talk about 3-4 of them just to give you get an idea about the loaders. So we are using HN loader here, which will load the content from Hacker News. Second is we are just displaying it, and let's look at the content loaded from Hacker News, this particular article. If you want to see this article, what this article is, let me just open this article in another tab. This is the Hacker News article from the which is loaded by the document loader, and we are printing this content from the loaded document, the text extracted. Second is the Gutenberg project. This project is actually hosting free to use articles and novels and books. And there's 75,000 free ebooks are available on this project, which are legally free to be used by anybody. So we are loading this project from Gutenberg, and then we are printing some content from the Gutenberg project. And this is the Gutenberg project loader. Second is URL and web pages. This time we are loading the content from a website like Paul Graham website, unstructured URL loader. So we have different loaders available for LangChain, which can load the content from various sources. Wherever the source is, wherever the data is, you can load the content or extract the text from that source and load it to be consumed by your chain or LangChain. Then text splitters. When you are searching for semantic similarity, your entire data may not fit into the context window of the embedding model. To make it fit into the model context window, you probably would want to split it into chunks, and that is where text splitters comes into picture. So we are using recursive character text splitters. There are 10 different types of 10 different types of text splitters available. And for this, we are using a sample content available in data directory, which I have uploaded in my directory here under data directory. So we are using this work.txt and loading it, and then we are splitting. This is right now one document, but I'm going to split it into chunk size of 150 with an overlap of 20. Why this overlap? What is the chunk size? Okay, chunk size is the size of the chunk which will be used to create embeddings in one go, and overlap is to keep the meaningful chunks, semantically similar chunks together, or connect the chunks which are semantically similar. That's what the text splitter, chunk size and overlap are used for. Now, after splitting the text, how many documents we have? 610 documents, and we are printing some of them here. From one document, we created chunks, and now we have 610 documents. Similarly, retrievers. Retrievers are used to retrieve the content from the vector store, maybe index. In short, the embeddings. So we need embedding model to first convert the text into embeddings, and then from using retriever, we are going to retrieve the meaningful content from the index, from the vector store. So here we are using easy way to combine documents in language model. There are many different type of retrievers available. We will be using this text loader, which will load our content from FIAS vector database, which will be in-memory vector store for us, and Ollama embeddings, which means that we will be creating embeddings using Ollama embedding. And data, this is the data which we will be using, that work.txt file. So importing corresponding packages. Now text splitter, we are using this splitter, chunk size 1000, chunk overlap 50, and using text splitters, and this is a model hosted on Ollama for embedding, generating embeddings. So create embeddings using Ollama embedding model on my local machine. I'm not sending any data out of my system team, out of my network. This is a completely local hosted, no internet connectivity needed to have this kind of solution developed. Initiate your retriever asking just one document back. So this is my retriever configured, and now I can retrieve the content, like what type of things did an author want to build from the document, and this will retrieve the meaningful content and print that. So this is a simple example of creating embeddings after the data is loaded using loader. The embeddings are stored into vector store, vector index, and then we are using a retriever to retrieve the meaningful, semantically similar content from the vector store, and this is what you can see here. Next is chat message history. If you want to interact with the model and you want to use the history of your previous message, you can use a chat message history also. For example, DeepSeek, we are using chat message history. That's how we define the message history. And I'm saying hi, and what is the capital of India. These are the two important things I want to be memorized, to be used. And you can see that history messages. AI message, content hi. Then human message, content, what is the capital of India. So these are the two messages, one which came from human, me, and second which came from the AI, because I'm using the word add AI message. This is a message for, which is representing AI, means the model. And this is user message, which is representing human, that is me. This can be incorporated and can be implemented in a software development, software projects. Now printing this history, printing the chat message history. So this will print my communication where what AI responded with and what user asked. So AI message and additional like what I sent. Similarly, AI message, response the content, add AI message. So this way you can see that AI message content hi, then human message what is the capital of India, then AI message what AI responded with. So this is a complete conversation history which can be used in LangChain. Then comes the agent. Agents make this whole concept dynamic, meaning that you give a toolkit to the agent the toolkit which consists of tools. And then agent will decide which tool needs to be called in order to answer the user question. So we are defining a toolkit here, which is made up of one LLM and second the SERPer API key, which is good for web search or internet search, or to be precise, it is a Google search API. So I'm using one LLM and second is Google search, which will make it very interesting case for me that I'm going to ask questions which is in today's date, and I'm defining the SERPer API key. So we have these two tools. So I'm defining this toolkit here with one is the SERPer API key, second is the model, and passing the SERPer API key. Initializing the agent with the toolkit and the model and the agent. So this is initializing the agent and this is my question which will go to the agent. Now agent will decide which tool needs to be called, whether internet search or the model. And you can see the response here. Okay, I need to find out current weather conditions outside Delhi today. I'm not exactly sure because the model have their own cutoff date. It is not expected from the model to respond to this question. And this is what you see here. It is calling the Google search API to respond with the model, and this is perfect temperature and humidity, and this is the response from the Google search using the SERPer API key. So any question which you feel that the answer lies in Google search or on some other agent, so you create a set of tools and you combine them together, put them together in the form of a toolkit, and you give the toolkit to the agent, and then agent will decide which tool needs to be called in order to respond to your question. Then this is chain, basic chain. Now we have understood the components like prompt, prompt template, document loaders, retrievers, toolkit, agents. With all these components together, let's build some chain. Easy to understand chain first. So chat Ollama, string output parser, chat template, so model, prompt and chain. Look at this, is simple sequential chain. Here we are defining the model, which is a DeepSeek-R1 chat Ollama, prompt, chat prompt template, tell me a joke about topic. Topic is going to be my variable which I'm going to pass while invoking the chain. So let's start from reverse. Chain.invoke, topic is BS. So this goes to a chain. The prompt, so it is calling prompt. Prompt is defined here from the prompt template. So this prompt becomes tell me a joke about BS. That goes to the model. Model is defined here, DeepSeek-R1. So that will be defined, and then string output parser. So this will make a simple sequential chain where the output of prompt goes to model and output of model goes to string output parser, where initial input is sent to the prompt through the variable or the placeholder, and where we are invoking the chain with the value of that variable. Then this is another simple sequential chain. This is interesting to observe. Template. Your job is to come up with a classic dish from the area that user suggests. Respond with the dish name and one-line description of it. And user location is what user will be invoking this LangChain with. And your response. So this is the template. And I'm defining this prompt template from this by supplying the user location. And this becomes my first chain, that is location chain. Let me execute this. So location chain defined. Now I'm creating a meal chain, where we are saying that give a short and simple recipe on how to make that dish at home. In this particular chain, we are going to take input from the first chain, which is classic dish. We are going to pass the output of chain 1 as input to chain 2. Means the second chain will give me the recipe or how to make that dish at home. So this is how I'm creating my meal chain, which is consisting of the LLM and the template. So this is my second chain, that is meal chain. Now let's connect two chains together. My overall chain is simple sequential chain with list of chains put into square bracket. That is, first is location chain, second is meal chain. It is implicit. You don't have to explicitly specify which variable will be generated and what variable will go to meal chain. It is implicit that output of meal chain will be put into the variable which is used in the second chain, which is user meal. So whatever the output generated by the first chain, we'll go to this variable user meal, and this will be substituted here, and hence the comprehensive prompt will become, give me a short and simple recipe how to make that dish home based on the output from the chain 1. So let's define the overall chain, and now I'm calling the chain with location name as Delhi. So what is the favorite dish at Delhi and how to make that dish at home is what you can expect from this chain, combining two chains together. Let's see, it is entering into simple sequential chain. Yes, so this is the chain, and this is location chain. I mean, the aloo gobi is the popular vegetable curry made for potatoes and mixed vegetable. Okay, and this is the recipe how to make that dish at home, and this is how to make it at home. Then we have the summarization chain. Here we are using this content from DISC, and we are trying to summarize it. So this is my summarization chain because I'm using function map reduce. The chain type is map reduce. So map re-rank, map reduce, there are multiple types of possibilities here and along with the model. So this is summarization chain. So this will summarize the content given in disc.text file, where text is extracted from the file, and this is summarized by this chain. All right. So this is all about LangChain team. We have understood various components of LangChain, simple sequential chain, summarization chain, and all the other components. I hope you enjoyed the session. Thank you very much for watching. Take care.